Alright, welcome back to my channel. So in this video, I will explain about the rate of change in differentiation topics. So in previous topics, we already learned the theory of optimization. So in this video, I will explain about the rate of change, and the STPM question usually come out with the rate of change questions. It add on the optimization process in the questions. Optimizations. Alright. So in rate of change, it requires you basic understanding on the theory. Let's say the volume of a sphere is 4/3 pi r cube, and the volume of a cylinder is pi r square h, and the volume of a cone is 1/3 pi r square h. So this basic formula you must know, like the velocity equals to displacement over time, so it's s over t, and the acceleration is velocity over time. Here is a basic physics formulas you need to understand it. So in order to do the rate of change of time, so let's say I have 500 milliliter of water I pour in 20 minutes, so the rate is 500 over 20, you get 25 milliliter over a minute. So the rate is actually over time, so it's d dt. So in doing the corrections in STPM, usually we need to generate our own formula, that is the related rate. We must find out the related rate. Let's say I have a variable x, so we can find the dx dt using this formula. In order we want to do the dy dx, so it's just like applying the chain rule. You want to find dy dt, dx dt, then we find the dy dx. In this case, we usually, the question will give you a given rate. The given rate usually is given the rate of velocity, so it's dv dt, and you are required to finding something like ds dt, so you must find something related like dt dx. You must find something like ds dv, then you relate this both, you can find this. So this is generate the rate. In these problems, you must generate your own solution and to combine with the given rate, then you applying chain rule to get the required rate. So this is how we doing the optimization and rate of change problems in the exam questions. So now I think I will further explain in the example that I will explain later. So now we go into small change. Actually, small changes is inside the syllabus, however it doesn't come up for so many years, so I think I can just explain some about it. So small change is actually, we know that dy dx, from the first principle we know dy dx equals to limit delta x approaches 0 del y over del x. Now limit delta x approaches 0 means that small change, or very small change in x. So the smaller the change, the more accurate the result, right? So now if we don't ignore these things, we are finding the dy dx, we let it become del y over del x. That means as long as my smaller change, and since the change is very small, so we can approach these terms. So we can change from here to here since the change is very small. So in the small change theory, we can apply this formula where if we want to find del y, it will be equivalent to dy dx times del x. So here is how we get a formula for this, and we find the final value of y. Let's say I have x, and I have y. So now I add some change of x. So some change of x I can calculate here. Then I have the dy dx. Let's say I have a y value, then I find the dy dx, I calculate del y del x, then I can calculate the del y. So I get the del y, so I plus the del y, so I get the answer is y plus del y. Here is my answer, the change in the y. Alright, so that we given a change in x, then you will need to find the change in y. Alright, let's say I give a simple example. Let's say the butcher sell 1 kg meat. The price is 30 ringgit. So now you plan to buy 8 kg of meat, but the butcher accidentally gave 8.02 kg. That means it's accidentally gave you extra 0.02 kg, right? So he said, oh sorry, I give you extra, so can I charge you for extra 1 ringgit? So do you think it makes sense? Let's check. So we know that 1 kg price is I'm30. However, now it's 8.02 kg, right? So you are doing, let's say x represent the kg of meat, and y represent the price. if you buy the 8 kg of meat, it's supposed to be 30 times 8, you will get 240 ringgit, right? So if you 8 kg, it's supposed to be 240. Now he accidentally plus del x. Your del x is actually 0.02 kg, so we will get 8.02 kg since del x equals to 0.02. And now what is the del y? It's supposed to be how? So let's say doing the solution in application, we know that y now is equal to 30x. Since x represents kg, right? So now it's 30x. X is variable. Since x represents kg, now x is 8 in this case, but however we are doing the x first, so now we divide the x, we will get 30, right? 30, we will get 30. So how you apply the small change formula? The del y equals to dy dx times the del x. So how is the del y? Del y equals to dy dx times the del x. Our dy dx is 30, and times the del x is 0.02. So pressing your calculator, you will get some answer like 30 times 0.02, and you will get 0.6 cent. So if the butchers sell you for I'm wanting it's actually not make sense. You can tell him, yeah, you can tell him it's actually 0.6 cents only. You shouldn't charge me for extra 1 ringgit. So it's actually the butcher already earned 40 cents. So from this case, we know how to apply the principles of doing the small change in the real life applications. So if the change is very small, then we can apply this formula. If the change is big, so we might use back the differentiation. So this is how we apply the small change in real life applications. However, I don't think it will come out because it's too easy. Since you only apply the dy dx equals to del y del x, then you find this formula, then you can find the del y, you add back and you get this formula. So, okay, let's see some questions. Let's see. In this exercise here, this exercise is about the rate of change. Now, a radius of a sphere is r, so it's r. So then the area of the sphere is 4 pi r squared. Here is very kind. It gives you the formula. So that is volume is 4 over 3 pi r cube. However, you need to memorize this formula because sometimes they are not given. When the radius of the sphere is 21 centimeters, when the radius is 21 centimeters, it is increasing at a rate of 0.01 centimeter per second. And now find the rates at which the surface and the volume are increasing at the same time. So here is very important questions. So you can see. So how are we going to do this question? So now we write down the information. We know the surface area. Let the surface area be A, be S, the S. Equals to 4 pi r squared. So what do we actually need to find? We need to find the rates at which the surface and the volume. That means we want to find the ds dt and dv dt, right? Are increasing at the same time. So how are we going to do this? So the surface area equals to s 4 pi r squared. So what is the variable here? It's r. So we don't have this. Actually, the given rate is actually here. You can see. I say in rate of change question, you need to find the given rate and generate rates, and you get the required rate. So in this case, what is the general rate? So you know that when the radius, so you highlight this, but when the radius of the sphere is 21 centimeter, it is increasing at a rate of 0.01 centimeter per second. So you know this is given rate. What is the given rate? It's actually dr dt. R is the radius, S is the surface area. Alright, so you can see the radius of the sphere is 21 centimeter, is increasing at a rate of 0.01 centimeter per second. So here is the given rate, is given dRdt. You want to find the ds dt. How are you going to find this? So from here, you know we can find ds dr, right? Ds dr, we get the answer is 8 pi r. So it's 8 pi r. So we have ds dr and dRdt. How we get to find this? You cancel r, right? So ds dt times dRdt. When you cancel out the I'm sorry, it should be ds dr, and you cancel out the dr and dr, you will get ds dt, right? So here is the answer. Yeah, so it's actually we need to find the given rate times with the generated rate. In this case, the generated rate is dsdr, and times with the ds, or is drdt, and we will get the required rate, what the question wants us to find. So in this problem, you must analyze this rate and you must generate your own formula using the s equals to 4 pi r squared, and you know how to differentiate it. If sometimes the question is not given this, you must able to figure out what we should do in steps, and you can find out the volume, surface area, anything you want to find, and you generate one formula that it can cancel each other to get the required rate. So now, to find this, since the DRTT is given, okay, let's write property surface area s equals to 4 pi r squared. So now you know that dsdr equals to 8 pi r. So you write down the formula dsdt equals to dsdr times drdt. The drdt is given when r equals to 21 centimeter, right? Then drdt equals to 0.01 centimeter per second. So now dsdt is actually equals to 8 pi 21, because the r is substitute 21, right? And times with 0.01, and you will get the answer is 42 over 25 pi meter square per centimeter. Yeah, so you get this answer, and if you want the exact value, is actually 5.28 centimeter square per second. So you can write down the surface area is increasing. Why I would say that this is increasing? Since the sign is actually positive, the rate can be positive or negative. If negative means it's decreasing, positive means that it's increasing, increasing. So now it's increasing at a rate of 5.28 centimeters square per second. So here is the answer. So now we're doing with the second part of the question. What is the second part? Find the rates at which the surface area and volume are increasing at the same time. It means that the radius is still 21 centimeters. So how are we going to find this? Is given the volume, right? Volume. So you already have the volume. So is it hard? Not really. You know that volume of sphere V is given radius 4 over 3 pi r cube. However, you need to memorize this formula. And now what we can find? This is a generated rate. And now we going to do is dVdr is 4 over 3, so we put down 3 here, will be 4 pi r squared, right? So you will notice that when r equals to 21, you are given a drdt, right? You use back the same thing, 0.01 centimeter squared is centimeter per second. So now we are finding the dVdt is actually the generate times the given rate. Here is the given rate. When you times back, you will get the required rate. dVdt equals to dVdr times with drdt, and hence you have the r is 21, so you substitute here, you will put 4 pi 21 square times with 0.01, and you get 55.42 centimeter cube per second. So here is the exact answer. The volume is increasing, since it's positive again, at a rate of 55.42 centimeter cube per second. So here is how we're going to deal with these questions. We must find. So the question will given a rate. Given rate is actually something, then it's like you relate it with the generated rate. And if you multiply it, you will see the chain rule. The chain rule is crossing out, and you will get dVdt. You get the required rate. What is needed in the answer. So here is how we solve the rate of change problems. So let's see the second question. Here is a model question. It's quite interesting. So a water storage tank having a shape of an inverted cone with the base of radius 6 centimeters and its height is 8 centimeters. The water is dripping out at a constant rate of 0.9 centimeter cube per second. So now I prefer you to draw out the shape. So the water tank is a inverted cone, so it's a cone here. Okay, it's a cone. So now the height is 8 centimeter is given. 8 centimeter, right? 8 centimeter, and the radius here is the base, inverted, right? It's inverted cone. So 8 centimeter here is 6 centimeter, and now water is dripping out That means the water is going out here. So at the rate of 0.9 centimeter cube, you can notice this is actually volume. So you know volume is actually negative 0.09 centimeter cube per second. Means that the volume of the water is decreasing. So what is the question required to find? If the depth of the water is h centimeter, express the volumes v centimeter cube in terms of h. Means that now the depth of water is not exactly a, but it's something like h. So here is the h, right? So we know that here got the new radius, right? Here is the new radius, so it's a radius r. So now how are we going to find this? So first I will tell you, if you see a cone, you don't be panic. It's actually we are not seeing the cone. We are not seeing the cone anymore. We are just seeing the cross-section area. What is means by cross-section area? So we are not actually interested in what cone, what the radius, what the heck. No. We are actually interested with the triangle. In SDPM question, we are focused in triangles. So how is the triangle go? So you can know that I will teach you a similar triangle theorem. So how we work with the triangle theorems? So let's say you can see these things. Let's say I have a triangle like this. I will tell you how to solve it. So let's say I have this triangle. So if my part here is L, let's say here is L and here is W width, right? And let's say I cut a triangle from here. I cut a small triangle. I cut here. Then I have a new value here, right? Here is, let's say, here is W prime, and here is L prime. So you know that actually L over W is equivalent to L prime or W prime, right? Because it's just a transform. You learn in the, I think you learn in Form 4, Form 5 that is the transformation. It's going to bigger out in the ratio. So it's actually the same triangle. It's going out in the bigger ratio, and until here is the biggest ratio. So the ratio are actually the same. So you can imply this formula to solve these questions. So how are we going to solve this? So let me delete this here. So let's show how we're going to do with this. We already have the 8 and 6. So how are we going to do? It's very easy. So now, it implies the similar triangle theorem. You can see, I want to deal with these two triangles. I hope you can see. So I will draw out the orange triangle. As you can see, here is a big triangle. Yeah. And the big triangle, you know here is 8. Whereas here is 6. Right. Now, you have the small triangle. Here is a red triangle where it's a H and R. You know here is the H and here is the R, right? Because it's 90 degrees, we can imply the similar triangle theorems. Now, how are we going to imply the similar triangle? We know that you can do anything. You can R over H is actually equivalent to 6 over 8. Yeah, so it's how we're gonna find it, express the term of R in terms of H, or we express the H in terms of R. So in this case, I want to express R in terms of H. So it's 6 over 8 H. So you get 3 over 4 H when you simplify. So this is how we find the R in terms of H. You can also reflect the back. It will be 4 over 3 R. H 1 H is equal to 4 over 3 R. So now we want to in terms of H. So I find it in terms of H. So we want to find the volume of it. Water. So what is the volume of the water? You know this is a cone, right? So I must say that volume of the water is the volume of the cone is 1 over 3 pi r square h. So now you have the r ready. Yeah, you just substitute the r since the answer 1 in terms of h. So is it the problem now? Yes, definitely no. So it's 1 over 3 over 4 h square. Then times with the h and you will get 1 over 3 pi, then here will be 9 over 16 h square h, then you will get 3 over 16 pi h cube centimeter cube. Here is the volume of the water. Here we find the answer. Since we already expressed the R in terms of h, then we substitute inside the basic knowledge you must have. Then we can get the answer really in terms of h. So here how we apply the similar triangle formula theorem for the cone questions, we are only interested in the parts of its cross section. We take out the triangle from this concept, and we can imply the concept and find the volume. So let's see the part B. Find the rate of decrease of the height of the water at the moment where the depth of the water is 4 centimeters. So now it's given H is equals to 4 centimeters. Find the rate of decreasing. That means the answer should be negative. In height of the water, that means you want to find the dH over dt. As I said, the rate is always in differentiate with respect to time. That means it's the change with respect to time. So now it's dH over dt. So what is the given rate? Actually, what is this? This is volume. So we have the volume. So is it a problem to find? Since our volume is in terms of H, actually here we know it generate rate, and you can see what is the given rate. Here is the given rate. The volume is dripping out, so it's dV dt. You can see actually the question is quite industry, so quite straightforward, and you know that dV dt is the given rate. Why is it that given? The given is I am dripping out at 0.9 centimeter cube per second. So you know it's 0.9 centimeter cube per second negative here, since it's decreasing. So you already know the given rate. So what you need to find? You need to find the dH dt. So you want to find dH dt. So you must generate a formula with dH dV. So I can cancel out each other. Where we can find the dH dV? Here. Here is the problems. So you have the volume in terms of H. So you can find dV dH. Then you 1 over answer, you will get dH dV, right? So now we have the volume equals 3 over 16 pi H cube. So we find the dV dH is actually, you take out the 3 here and you get 9 over 16 pi H squared. So now you have the dV dH. You want to, here is the generated rate. As I said, in this case, you want to find the dH dt. dH dt is actually equivalent to the dH over dV times with the dV dt. Hence, you can cancel out. It will be the same. So here is 1 over 9 over 16 pi H squared times with the dV dt is given is negative 0.9. And you have the H, right? Because the question is given the H is 4 centimeters. And you substitute 4 here, you will get 1 over 9 over 16 pi 4 square, and the 4 square, and this will cancel out, times negative 0.9, and we get the answer is 0.032 negative centimeter per second. So here is how we find the answer. So the answer is the rate of decreasing in height of water is negative, because we mentioned decreasing here already, so we don't need to mention negative already, 0.03 centimeter per second. So here is how we find the answer. We must ask the same thing. I will say we need to find a general rate ourselves, and the question will give a given rate. When we multiply or divide it, we will get the required rate. That is the answer. So here is the strategy how we're gonna solve the rate of change problems. So I think I will explain the STPM question in the next video, and I will explain some further extra knowledge questions that is a very hard question. So I think here I will end my video. Thanks for watching.